the next unit you guys are going to learn is about sequences and series. Let's first, before we get into the one we're going to deal with today with it, which is arithmetic sequence, let's define a sequence. So a sequence is a list of numbers or terms in a specific order. And this sequence, there's a bunch of sequences, but the ones that you guys are going to learn about in this lesson are ones that are going to be added or subtracted to get to the next number. So essentially, here's something that you might see on like an ACT or a math entrance exam, where they give you find the next 4 terms in this sequence, and a lot of people will go through and just try to guess, and sometimes that's easy. Like for this one, we have 55. The way to get to 49 is just to subtract 6 each time. So if I subtract 6, I get 49. If I subtract 6 again, I get 43, and so on. If I subtract 6 again, I get 37, and then 31, 25, 19, and so on. So a lot of times you can just guess, and that is an arithmetic sequence, so something that is added or subtracted to get to the next number. Now there's also an equation that goes with this, so if you were asked a more complicated question and you couldn't actually just guess, this will help you out a lot. So the formula for an arithmetic sequence is a to the n, meaning whatever term you want to end up at, is equal to your starting term, a1, plus the number of terms you're talking about, minus 1, times the common difference. So let's label these. This will be your nth term or ending term, right? This is your initial term. This is the number of terms, or of the term, I should say, that you want. And D is the common difference. So in our case, the common difference for this last problem is -6. Okay, the initial term was 55, the ending term was 19, and we had 7 terms that we listed. So that's an example of how that would fit into that sequence. Let's do an example. So find the indicated term for the arithmetic sequence if I give you the starting term, the difference, and the number of terms that I want. So we're going to actually go ahead and fill in our formula, which will be pretty easy now that we have that formula. You don't have to guess so much. So let's take a look at that. We have a1, so that's what we're looking for, or an, I'm sorry, is what we're looking for, equals 3, that's our a1, plus the number of terms we want, so the 14th term, so 14 minus 1, and then the common difference is 7, so that's what we're going to put there. Okay, and then we actually multiply that out, and that's going to be our final answer. So in this case, we would get 13 times 7 plus 1, which is 94. So a to the n equals 94. Pretty easy. And if we had to do a guess and check method, it would take us a really long time. So let's try another example. Find the 4 arithmetic means between 16 and 91. I want you to just look at this word arithmetic means for a second. And that just means numbers that are in between. So for example, it would be like 16, there'd be 4 numbers in between, so 1, 2, 3, 4, and then 91. That is the arithmetic means. Okay. To do this, I'm going to use my equation. I'm going to use this an equals a1 plus n minus 1 times d. And I don't know the difference to get to 91. I don't know what that is. So what I'm going to do is actually plug in the things I do know. I know that my ending term is 91, so I'm going to plug in 91 for an. I know what my initial term is, that's 16. And then plus the number of terms is actually 1, 2, 3, 4, 5, 6. So a to the n is 6. That'll be 6 minus 1 times d. And we actually just have to solve for d. So let's do that. We get 91 equals 16 plus 5d. Subtract 16 and divide by 5. And we get that d is equal to 15. So we now have to divide by 15 each time. So we're going to do, or not divide, add 15 each time. So 16 plus 15 is equal to 31. So that's what I'm going to put here. 31 plus 15 is 46. 46 plus 15 is 61. And then 76, and then 91. So those are your answers. And that's going to be your arithmetic sequence. Arithmetic series is the next part of what I'm going to teach you for today. I know it's lesson 2, but you guys are honors advanced, so rock it out. Arithmetic series. So a series is a little bit different from a sequence in the fact that it's a sum of some numbers. So an arithmetic series is an indicated sum of terms of a sequence. So it's like taking a sequence and just adding all the numbers together. Okay. Let's take a look at some examples. So the sum Sn of the first n terms of an arithmetic series is given by, and this is an equation as well. I'm sure that you could probably eyeball it and figure it out on your own, but it's almost better if you just have this equation handy. So the equation would be Sn, which is the sum of n numbers, equals n over 2 times a1 plus an. Okay? And obviously a1 is the initial number, final term, this is the sum, and n is the number of terms that you're adding all together. So let's take a look at an example. Find the sum of the first 100 positive integers. So obviously we have to write down the things that we know. The first number, if I go from 1 to 100, that means my initial number is going to be 1. My final number, a to the n, is 100. And my number of terms is actually 100 as well. So now let's fill this in. So we get the sum n equals n over 2 times a1 plus a to the n. We're going to fill in what we know. So we get 100 divided by 2, and then 1 plus 100. And we get that this is equal to 5,050. That would be the sum. So you're just going to plug and check. Let's do another example, and then we'll get to the last part of the lesson. So find the first 3 terms of an arithmetic series if they give you some things. So anytime they're giving you a given and you have to find something, just plug in the stuff that you know and see if you can find the rest. So first of all, our equation is Sn equals n over 2 times a1 plus a to the n. Okay? We got to figure out what n is first before we do anything. So we know the sum, it's 741 equals n, so we don't know what that is, over 2. a1 is 9, and a to the n is 105. So we're going to solve for that. We get 9 plus 105 divided by 2, multiplied over, we get n is equal to 13. So we have 13 terms in this arithmetic series, and we want to find the first 3 terms. So to do that, we probably have to find the difference mean, or the common difference. Okay. To do that, we're going to go back to our series equation, and that is just something that helps us relate what term beginning and an ending term with a difference between. So let's take a look at that. We have a to the n equals a1 plus n minus 1 times d. We can plug in a1, a2, and a3. So we know that a1 is equal to 9, okay? a2 is just going to be 9 plus 8, which is 17. And a3 is equal to 17 plus 8, which is 25. So those are our first three terms. Now, the last thing I want to talk to you guys about today is sum notation. So sigma notation, essentially. And sigma notation is a nicer way of writing the word sum, so adding, okay? And it looks like that little E, I guess, and it means sum, or a summation. And we're going to just label what these different parts actually mean. So let's take a look at that. First of all, this is your initial starting, so your first value, or your initial value of n. This is your final value, and this in here is the formula for a series. So you're going to just put that series that you're trying to add all together. And obviously that this sigma. Alright. Let's do an example. Evaluate the sum starting at j equals 5. Oh, and n is the index. So that's just in terms of what you're summing together. So let's take a look at this guy. To begin with, we have j equals 5. So that means we're starting out a1 where you're plugging in 5. And we have a summation. So we know that a1 is going to equal 5 in our equation here. So we get 3 times 5 minus 4, which is 11. Okay? And we want to find the first, you're going from j equals 5 to j equals 8. So that's 5, 6, 7, 8. That's 4 terms. So n is equal to 4. Okay? That means that a to the n, or a to the 4, would have to be where you plug in 8. So it'll be 3 times 8 minus 4, which is equal to 20. And why are we finding all this stuff? Well, because we're going to plug it in. You could actually, you could add it up if you wanted to on your calculator, but it would take a long time. So we're going to put it in our sum equation. So Sn is equal to n over 2 times a1 plus an. And then I can just fill in the stuff I know. 4 over 2, and a1 is going to be 11, a to the n is 20. And I end up getting 16. So that's how I would write my summation equation. Tomorrow we're going to go over some homework, and this will be your homework for tonight. So thanks, and I'll see you guys next time. Bye.